Let's look at a few more things from the Essentials of Networking chapter. Let's start off here with a typical LAN. So LAN, or local area network, is what we typically refer to when we're referring to computers in a room or in a single building. So some key points of a local area network is there's usually a switch involved. Typically at the center of the star topology logically, though you might actually have several switches connected together. So you see the ones that we have here. Here is one local area network on the left and another separate one on the right. But if we were to come out of this switch and connect these two together, now we would have one local area network with two switches sort of at the center. So this would be an extended star. So there's one switch connected to another switch, and each one of them has devices hanging off of it like that. So for the most part, when we talk about LANs, we're usually talking about wired Ethernet, typically copper, sometimes fiber, and then oftentimes we're going to throw some Wi-Fi in there as well. And that could be done with a Wi-Fi router or just a wireless access point, which kind of acts like a switch for wireless. Sometimes, though, you can't run cables, and Wi-Fi also doesn't work for whatever reason. Possibly you're in an older home, and the older home maybe has mesh in the wall for the plaster. Well, that mesh can mean that Wi-Fi doesn't work very well between walls. The wireless signal gets dispersed. And so, let's say you're in a rental property. You can't actually go digging in the walls to run your own cables, and you don't want to run them over the floor. So one option here is this power line Ethernet. So what you do is you simply plug in this device into a power outlet, and you can see down here, it's got an Ethernet cable coming out of it. So you can plug these in anywhere in your home. And now what you're doing is putting data on your home's internal power. And now you have a wired local area network in your home without having to, chip into walls or run cables. So that's one option. Structured cabling. So when we talk about structured cabling, what we usually mean is permanently installed cabling in a home or a business. So if we think about what we did in our classroom, we ran all of those cables through the ceiling and sometimes down into the walls and into the channels that run around the classroom. That is all part of structured cabling. Whereas when we run a cable from the switch just across the floor, that's not really structured cabling because that's meant to be temporary. So structured cabling is the permanent installed cabling. And so when we have this structured cabling, there's a few key words we want to look at. One is horizontal cabling. So the horizontal cabling is the long run that happens usually in a ceiling or in a cable tray, or it could even run under the floor, which is pretty common in some server rooms. And it's called horizontal cabling because, of course, it runs horizontal or parallel to the floor. Now, what they've done here, and this is a very common way of cabling, is to run it to a dedicated spot in a telecom room or telecommunications room. So in our classroom, ours is actually exposed. We have that rack that sits right in the middle of the classroom. That would be our equivalent of the telecommunications room. That's the center or the hub of everything. And everything runs up into the ceiling and out from there into the individual workstations, into our closet where we have some servers. But typically it's going to be, behind a locked door or somewhere inaccessible because it's not pretty. So there's our horizontal cabling. Here's a little bit about some cable, which we've already covered Ethernet cables separately, so I'm not going to go over that right now. Equipment racks. So an equipment rack could be a 2-post or a 4-post rack, referring to how many uprights there are. 2-post racks are used for a lot of networking gear. You want 4 posts if you're going to put in servers, because servers are really heavy and they're so large that you need some support in the back of them. So racks in general are 19 inches wide, and they're measured in U's or rack units in height. So it can be anywhere from, just a few, like a 2 or a 4U rack, all the way up to 42. 42, I think, is your standard height, like the equipment rack in our room. So here you can see a 4U server rack, a 4-poster. So it's got 1, 2, 3, 4 posts that hold things up from each corner. And there's an example of a 2U that looks like a UPS. So a U is 1.75 inches tall. So this one being 2, you know, this is going to be there's going to be a separation right there. So you have 1 and 2, and each U has 3 screw holes, and they're not evenly spaced. So you need to put your servers or switches or whatever in the correct screw holes so that things line up. You can't offset it by 1, or it won't line up properly. So if we come over to, let's say here, I pulled this image off of Home Lab on Reddit, and what you see here is a Dell server that's 1U in size, so that's 1.75 inches. Here's a couple of networking switches that are also 1U. And then this server or NAS or whatever it is down here looks like it's probably 3U. So it's not uncommon to have a 1 or a 2 or even a 3 or 4U server. Once you get over that, you're getting pretty big. But sometimes you find some networking gear, large Cisco switches and routers that might be, you know, 12U tall. So those are going to be huge pieces of equipment. We've got some patch panels. Patch panels, kind of the same way. They take up, you know, here's a 1U patch panel and a 2U patch panel on top. We did a little bit of practice with this, but I wanted to point out 2 different types of punch blocks in the back. You have a 110 and a 66. So if I come over here, this is the 110 punch block. This is what we practiced with in the classroom. So you have your Ethernet cable that comes in, you untwist the wire, you lay it across this little area right here. So it goes like that. And then when you punch it down, it gets pushed into the connector, and there's a couple little sort of knife blades that cut into the sheath and make an electrical connection to the wire inside. So that's the 110, and the 110 is what we typically use for Ethernet. But there also exists a 66, and the 66 is much more common for telecommunications. So this is what old phone lines would use. We don't find the 66 so much here in our networking world. But the way this one works is you use the same punch down tool, you just put a different end on it. And you run your wire into this block right here, and your punch goes all the way around this little block. And then when you push in, it gets kind of the same thing, right? There's a sort of a right and a left-hand side, and it gets cut a little bit, cuts into the sheath and makes an electrical connection in much the same way. So this is the 66, which we don't see nearly as often. And then we have the 110 over here, which is much more common for us networking guys. And there you see the patch panels. Patch panels are rated just like cables. You got Cat 5, Cat 5e, Cat 6. Typically, you don't want to have to re-punch a patch panel. So you want to install a patch panel with the best thing that you can afford. So if we're looking at Cat 6 or Cat 6a right now, I probably would not install a 5 or a 5e anymore if I could help it, because you do not want to redo all that work. And then that's more on how to punch cables or make cables, which we've done. We've got the RJ45s. So one last bit from this chapter, a wide area network or a WAN. So what's the difference between a LAN and a WAN? Well, so LAN is local area network versus wide area network. So a local area network is usually a switch with several devices hanging off of it, maybe several switches, and these switches could be, you know, Ethernet, copper Ethernet. They might be fiber. So you might have a fiber cable running over to another switch over here with more devices. So that would be common in a LAN. With a WAN, you usually have a router involved. So a router is going to separate into separate networks that allows those 2 networks or more to talk to each other. Some other differences. WANs are usually geographically larger, but there's no hard and fast rule about that. You might have 2 or 3 buildings on a campus made up of one LAN, or maybe you choose to treat them as each building as a separate LAN that are connected, which turns them into a WAN. It just depends on how you look at it. Another possible difference is sometimes WANs, we go over leased lines. So in this local area network, we own the switches, we own the cables. With a wide area network, think about how the schools connect to each other. So we've got Hoosier Hills over here, and then we've got Bloomington South over here. And these are totally across town. Well, these 2 campuses can communicate with each other. we can put a server at South and access it from Hoosier Hills if we set it up properly. However, we don't actually own a cable that directly connects these two things together. Instead, what happens is Hoosier Hills connects to North, and North connects to Smithville. So now we're going to draw a cloud. So this is a leased line. We don't own this portion right here. Smithville does, and we pay for the access. Similarly, Smithville has the connection to South. We don't own this. We just pay for access. So what we're doing is paying another company to connect our buildings together. So these going over a leased line is sometimes how we would define a WAN as well. So there's a few differences between WANs and LANs.